एग्जाम्स का हो चुका है आगाज, लाखों एस्पिरेंट से रणभूमि है तैयार। अब योद्धाओं के सर सजेगा ताज, क्योंकि हो चुका है सिलेक्शन का शंखनाद। जी हां दोस्तों, अब तैयारी होगी टेस्ट बुक सुपर कोचिंग के साथ, जहां आपको मिलेगा अप टू 90% ऑफ। 7 और 8 जून को होगा सिलेक्शन का शंखनाद सेल। तो अगर आप एसएससी, बैंकिंग, टीचिंग, ईपीएफओ, यूपीएससी, स्टेट पीएससी, यूजीसी नेट, सीएसआईआर नेट, एजेई, गेट और डिफेंस जैसे एग्जाम की तैयारी कर रहे हैं, तो अभी जाइए और इस ऑफर का लाभ उठाइए।
Hi, good evening, everyone. This is Shefali Sengla, and in this session, we are going to talk about sorting techniques. So, yesterday we had a look over the properties of sorting technique. We talked about when can we say an algorithm is adaptive, it is in place, or it is stable. So, I hope that you guys are comfortable with that. We had discussion over the merge sort, whether it is in place or not, it's stable or not, and same happens with a quick sort. Apart from that, we also talked about the time complexities, best case and the worst case. Since a merge sort and quick sort are divide and conquer applications, so that's why we were using the recursive call to sort the elements, and for that we had written the recurrence relation. So anyone having any doubt in the recurrence relation of merge sort or quick sort? I'll not be asking about the complexity, because if you are clear with the recurrence relation, then easily you can find out the complexities. So anyone having any query? In today's session, we will be talking about the next three sorting techniques: insertion sort, selection sort, and bubble sort. Heap sort बचेगा, वो हम लोग कल करेंगे, because heap sort से पहले I want to discuss the concepts of heap tree. So it's there in our syllabus in the data structures, but we'll finish here. We'll understand that what is heap tree, how to construct the heap tree, what sort of questions can be asked on heap tree. So lot many questions have been asked. तो कल वाला जो सेशन होगा, इट विल बी अ कंबाइंड सेशन फ्रॉम डेटा स्ट्रक्चर्स एंड एल्गोरिथम्स. ओके, वेरी गुड इवनिंग कंचन. I guess there was no doubt. So let's jump to the first sorting technique, insertion sort. उससे पहले देख लेते हैं कि stable comparison. तीनों sorting techniques के लिए we will be finding the time complexities, the properties. So stable का मतलब होता है कि अगर आपके पास same keys given है, ओके, सेम वैल्यू है कीज की, तो सॉर्टिंग के बाद भी उनका जो ऑर्डर है दैट इज नॉट चेंजिंग. इट्स रिलेटेड टू द वैल्यू ऑफ द कीज. ओके, एंड कंपैरिजन इज, जितनी भी हम ये सॉर्टिंग टेक्निक्स कर रहे हैं, वी आर कंपेयरिंग द कीज एंड आफ्टर दैट वी आर finding the smaller element or the greater element. तो comparison करके हम sort कर रहे हैं. So that's why these sorting techniques, whatever we are covering, these are the comparison based sorting techniques. Next one is adaptive. Adaptive says that if the pre-sortedness of the elements is taken into the consideration, then it is known as adaptive. This simply means that अगर कोई भी algorithm बेस्ट केस और वर्स्ट केस में डिफरेंट बिहेवियर शो कर रहा है, इट इज टेकिंग डिफरेंट टाइम कॉम्प्लेक्सिटी, सो इट इज अडेप्टिव. ओके, सो apart from this, we had also talked about the in place. In place means अगर आपको sorting करने के लिए some extra space is required, then it is not in place, but if the same space is used, then it is in place. तो सिंपल सा तरीका मैंने बताया था, ज्यादा कॉम्प्लेक्स करने की जरूरत नहीं है. अगर स्वैपिंग हो रही है, स्वैपिंग मींस एलिमेंट्स की अदला बदली हो रही है, तो वो ऑब्वियसली सेम एरे के अंदर हो रही होगी. सो दैट मींस इन दैट एल्गोरिथम वी आर यूजिंग द that algorithm is the in place sorting algorithm. Okay, simply this is all what you have to do. I'll be sharing the PDF of this सेशन इन द टेलीग्राम ग्रुप, दैट इज शेफाली मैम टेस्ट बुक. हर सेशन की मैं पीडीएफ शेयर करती हूँ, जो भी प्री टाइप्ड कंटेंट है और वॉट एवर आई बी राइटिंग ड्यूरिंग द सेशन, everything there will be there in the PDF. So you need not to worry about getting the notes or getting the PDF. I'll be providing this. ओके, तो सेशन में आपका फोकस सिर्फ और सिर्फ अंडरस्टैंडिंग पे होना चाहिए, क्योंकि चीजें बेटा लिखी हुई तो आपको बहुत जगह पे मिल जाएंगी. द थिंग इज की क्लैरिटी. concept clarity. Okay, so I'll be sharing the daily PDF of all the YouTube sessions, and the in this Telegram group discussion and doubt solving session will be there. You can directly interact with me, and you can also participate in the quiz and the poll. आप Telegram group join करने के लिए search भी कर सकते हो, और description के अंदर third link जो है वो इस group का है, so you can join the group through that link. All right. So first of all, insertion sort. Insertion sort is one of the very simple sorting technique, but definitely it will not be used for large number of elements. It is suitable for small size problem. इंसर्शन सॉर्ट के लिए एक सिंपल सा एग्जांपल लेते हैं हम, प्लेइंग कार्ड्स, जिसे हम ताश के पत्ते बोल देते। तो एक गेम होता है ना, एवरी प्लेयर इज असाइन विद लाइक 10 कार्ड, सपोज 10 कार्ड्स गिवन है, एंड यू पिक वन कार्ड, कार्ड को निकालते हो, करेक्ट पोजीशन देखते हो, यू प्लेस दैट कार्ड ऑन इट्स करेक्ट पोजीशन, देन यू टेक आउट द नेक्स्ट कार्ड और उसको फिर एडजस्ट कर देते हो। सो दिस वे वी आर गोइंग टू सॉर्ट ऑल द कार्ड्स. That is nothing but that is insertion sort. So what I'm saying is, in every iteration, we are going to select one card, and we are placing that card on its correct position, right? So the simplest, it is the simplest comparison based sorting technique. Let's talk about one example. I'm going to take input. Input is 50, 40, 30, 20, and 10. Obviously, these elements are available in the array. If you observe this array is already sorted in the descending order. Let us assume that the goal is to arrange the elements in the ascending order. To arrange these elements in ascending order. But जो आपको input given है, that is in the reverse order. We are given that in the descending order. So what we'll do is, in pass 1, we'll be taking the first element. In pass 1, I'll be taking the first element. Array remains the same. So first element, जब आपने एक ही element consider किया, इससे पहले कोई elements नहीं है, तो definitely this element will be on its correct position. So if we represent here it comes out to be, we will be having the output as 50, because this is on its correct position. This is pass 1, 30, 20, and 10. So in this case, when I took this element, I wanted to compare it with the other elements before this, क्योंकि इसके बाद वाले जो elements है अभी तक हमारे लिए वो unsorted problem है. So in this case, before this, since there is no element, so no comparison. Let us write here the number of comparisons and number of swaps. Okay, so in this case, there is no comparison taking place in pass 1 and no swap is taking place in pass 1. Let's go to pass 2. This is about pass 1. Pass 2. Now 50 is on its correct position. We have to adjust, take the next element 40. Very good evening, Prashant. अब हमें 40 को adjust करना है. So what I'll be doing is, I'll be comparing this 40 with 50. So 40 is smaller because I want to arrange the elements in the ascending order. So 40 is smaller than 50. Then we will be swapping these two elements. तो यहाँ पे क्या होगा? First swap will take place, and here we'll get 40, 50, 30, 20, and 10. Right? So यहाँ पे we had performed the first swap क्योंकि ये elements, the first element is greater than the second element, so पहला swap हुआ. Here we'll get 50. After that, before this, is there any element? No other element is there. So in pass 2, in order to place the element at its correct position, how many comparisons took place? See, insertion sort is all about the comparisons and the number of swaps. We won't be writing here the translation. On the number of comparisons and number of swaps, we will be talking about the time complexity. So how many comparisons are taking place. 40 was just compared with 50, so one comparison and one swap is taking place. Basically, this is behaving as the worst case of the insertion sort. This is the example for the worst case, right? In the pass 3, now by the end of pass 2, two elements are on its correct position. Now we'll go to pass 3. In the pass 3, input that we are getting is, as of now, we have 40. Output from the previous pass that we are getting is 40, 50, 30, 20 and 10. Properties मैं नहीं बताऊंगी, आप बताओगे. You just need to understand what we are talking about. Now, we'll be talking about 30 element 3. So this is already sorted. So 30 will be compared with 50 first. 30 is smaller than 50, so these two elements will be swapped. Here we'll get 50 and 30. Then 30 will be compared with 40, and 30 is smaller, so second swap will take place. Here we'll get 40 and here we'll get 30. So if you observe here, two comparisons and two swaps are taking place. Two comparisons and two swaps. This is the output after pass 3. So let's go to pass 4. Pass 4 means we need to consider the fourth element of the array. As of now, the output is, we have the output as 30, 40. By the end of pass 3, three elements are sorted. This is 20 and this is 10. Now we'll be taking the fourth element. Fourth element is 20. 20 will be compared with 50 since 20 is smaller than 50. So the first swap will take place. Here we'll get 50 and here we'll get 20. Now 20 will be compared with 40 since 20 is smaller. So 20 will be swapped with 40. This is the second swap. First swap, second swap. Now 20 will be compared with 30. Since 20 is smaller, so we'll swap 20 and 30. And this is the third swap. So in pass 4, three comparisons and three swaps are taking place. Property समझ में आ रही है? Pass 5. Pass 5 means I'll be talking about the fifth element. Now we'll be considering the fifth element. So for pass 5, input is, if you look at this array elements are 20, 30, 40, 50. This means that by the end of pass 4, four elements are sorted. Now we'll be considering the fifth element. For fifth element, how many comparisons and swaps will take place? This is the first comparison. 10 is smaller, so 10 will be swapped with 50. Next, 10 will be compared with 40. 10 is smaller than 40, so it will be swapped with 40. 10 will be compared with 30. This is smaller, so here we'll get 10 and 30. Next, 10 will be compared with 20. Here we'll get 10 and 20. So basically, how many comparisons and swaps took place? This is first comparison, second comparison, third comparison. I'm so sorry. First comparison, second comparison, third comparison and fourth comparison. Four comparisons, और हर बार जब हमने comparison किया, we are getting that the element that we are going to place on its correct position is smaller, so we are going to swap it. So in the worst case, in the past 5, there are 4 comparisons and 4 swaps taking place. Yes? ये clear हुआ? अगर आपके पास, यहाँ पे हमने छोटी problem ली है with 5 elements only, so just let me know if we'll be having here n passes. If n passes are there, okay, pass n, then what will be the number of comparisons and swap? If it's the first pass, then we are having 0 comparison and 0 swap. If it is pass 2, we are having 1 comparison and 1 pass. If it is pass 3, then 2 comparisons and 2 passes. For pass 4, it is 3 comparisons and 3 passes, 3 swaps. So what will be the number of comparisons and the number of swaps in the pass n? Worst case में कितने comparisons और passes आएंगे? Not the passes, number of comparisons and number of swaps. Come on, guys. You can observe the pattern here. For 1, it is 0. For 2, it is 1. For 3, it is 2. For 4, it is 3. For pass 5, it is 4. So this means that if we are talking about nth pass, Here the number of comparisons will be n minus 1 and number of swaps, I hope it's not going behind the image, and number of, okay, let me hide this, and number of swaps will also be n minus 1. Make sense? Now we want to find out the time complexity. For this, what we'll be doing is, if we find out the total number of comparisons will be 1 plus 2 plus 3 plus 4, or let me write here total number of comparisons, and in this case the number of swaps are also the same, so total number of comparisons will be equal to 1 plus 2 plus 3 and so on up to n minus 1. This is nothing but this is this natural sum series. We know that the formula is n into n plus 1 divided by 2, where n represents the number of terms. यहाँ पे number of terms n minus 1 n. So we'll be getting here n minus 1 divided by 2. How I'm getting this? Normally the formula is n into n plus 1 divided by 2, but यहाँ पे n की value is number of terms are n minus 1. So I'm substituting n minus 1 plus 1 divided by 2. So it comes out to be n into n minus 1 divided by 2. That is nothing but approximately order of n square. And that is nothing but that is the worst case time complexity for insertion sort. You can consider the number of swaps or you can consider the number of comparisons. Total number of swaps are also the same in this case. Total number of swaps are also n square. ये clear हुआ? So worst case time complexity for insertion sort is order of n square. Now let's talk about the best case. Best case कौन सा होगा? What will be the best case here? Best case simply says that if you want to sort the elements in the ascending order, given input is also in the ascending order. So let's talk about the best case, and the input given is elements are given in the ascending order and goal is to arrange the elements in the ascending order. It's 10, 20, 30, 40 and 50. Goal is to sort the elements in the ascending order. Okay, this is already in the ascending order. So if I go to pass 1, तो यहाँ पे क्या करेंगे? Simply we have to find out the number of comparisons and number of swaps. So if you consider, in the past 1 will be targeting on the first element, so 10 will be compared with the element or the elements which are present before 10, but before this there is no element, so no comparison is required, no swap is required. Then we'll go to pass 2. In the pass 2 we'll be considering the second element, so I'll be comparing 30, 40 and 50. So I'll be considering this element 20 and I'll be comparing it with 10. 20 is smaller than 10? No. अगर 10 से smaller नहीं है तो इसके आगे कोई भी elements होते हैं उनसे भी smaller नहीं होता, because whatever elements are present on the left hand side, those are already sorted. So in this case, one comparison is taking place. Kindly increase your sound, ma'am. So guys, am I not audible? How many of you are having a problem with the sound? कितने लोगों को वॉल्यूम का प्रॉब्लम है? Okay, n minus 1 will be the total number of comparisons. Yeah, that's right. So in this case, zero swap is taking place. कोई swap नहीं आ रहा है pass 3 में. In pass 3, Input is 10, 20, 30, 40, 50. This is 10, 20, 30, 40, 50. अब यहाँ पे हम third element को consider करेंगे. Third element is compared with the second element. 30 is compared with the 20. Is 30 smaller than 20? No. So इसके बाद हम 10 के साथ comparison नहीं करेंगे क्योंकि 20 से पहले जो भी elements होंगे those must be smaller than 20. अगर 20 से ही smaller है तो 30 से तो smaller होंगे. So that's why we'll just stop here. One comparison and zero swap is taking place. In pass 4 means now we are considering the fourth element 40. 40 will be compared with 30. This is 20, 30, 40 and 50. 40 is compared with 30. 40 is smaller. 40 is greater than 30. So no swapping is taking place, zero swap. Similarly, we'll go for pass 5, that is for the fifth element, 50 will be compared just with 40. 10, 20, 30, 40, 50. So in this case, can you tell me that what will be the time complexity? So this way, if we'll go to pass nth pass maybe, it will be taking one comparison and no swap. अगर हम total number of comparisons find करते हैं, if we find out the total number of comparisons here, total number of comparisons, कितने comparisons हो रहे हैं? n पास है, पहले पास में कोई comparison नहीं हो रहा, बाकी के remaining n minus 1 passes में only one comparison is taking place. So this comes out to be 1 plus 1 plus 1. How many times? N minus 1 times. So this is going to return n minus 1. N minus 1 is nothing but that means it is order of n. तो हम ये बोल सकते हैं कि best case time complexity for insertion sort is, it is omega of, because best case के लिए हम omega notation use करते हैं, so it is omega of n. Easy, simple. So on the first slide, I took the worst case scenario. We are just doing the comparisons and finding the number of swaps required. And in the insertion sort best case, again, we took one example. We calculated the number of comparisons and the number of swaps. So I hope that this is clear to everyone. The complexities are clear, right? Okay. So here for insertion sort, we have said that the best case time complexity is omega of n, and if we talk about the worst case time complexity, that is order of n square. Okay, done. After that, is this in place sorting technique? अब properties पे आ जाओ, आपको मालूम है, थोड़ा सा sound increase. From my side, it is full. Properties पे आ जाओ. Is it in place? हमने कहीं पे भी extra space लिया? Come on guys, तीन चीजें चेक करनी है, in place, stable and adaptive. ओमेगा ऑफ एन वो ठीक है, क्लियर भी ठीक है. प्रॉपर्टीज, इज इट इन प्लेस? जस्ट हैव अ लुक ओवर द एग्जांपल. कहीं पे हमने एक्स्ट्रा, ये जो आपको दिख रहा है ये सिर्फ मैंने पास में इनपुट दिखाने के लिए किए. जो भी यहाँ पे आपके पास इनपुट थी दैट इज गोइंग टू द नेक्स्ट पास. जो भी यहाँ पे फाइनल आउटपुट था दैट इज कंसिडर्ड एज द इनपुट, राइट? तो अलग से एरेज ये नहीं बन रहे. सेम एरे के अंदर हम कंपैरिजन कर रहे हैं. अगर हमें स्मॉलर एलिमेंट मिल जाते हैं देन वी आर सिंपली स्वैपिंग द एलिमेंट्स. नो मैम. सो इजंट इट इन प्लेस? एक्स्ट्रा स्पेस कहां पे ली? सिंपली I can say that आपके पास इनपुट गिवन थी, अगर मैं एक ही एरे में करती तो ये बहुत हौच पौच दिखता आप लोगों को, 30 and 20. So what I did is 40 was compared with 50, 40 and 50 were swapped. Then 30 was compared with 50, then we got 30 here, then we got 50, and then 30 was swapped with 40. Then 20 was compared here, so 20 and 50 will be swapped, 20, 20 and 40 will be swapped, 20 and 40, 20 and 30 will be swapped, 20 and 30. So are we taking the extra space? No. So this means that insertion sort is an in-place sorting technique. What about adaptive? In-place sorting technique. Insertion sort is in-place sorting technique. What about adaptive? Is it considering the pre-sortedness of the elements into the consideration? Is it impacting the time complexities in the best case and the worst case? कोई impact आ रहा है? No. So, sorry, yes. अगर आपके पास elements reverse order में given है तो time complexity n square है. अगर same order में sorted है then time complexity is n. This means that it is insertion sort is one of the adaptive sorting technique. What about stability? Is it stable? In place है, adaptive है. What about stability? Is it stable? Stable का मतलब होता है अगर आपके पास same values हैं keys की, then their relative ordering will be same. For example, A, B, C, D. So if you observe here, I'll be taking 10. 10 will be compared with 10. Is it smaller? No. So there will be no change. Take the next element. 10 is smaller than 10? No. 10 is smaller than 10? No. So this will be the output. This means that here the relative ordering of the keys is not going to change. So we can say that it is a stable sorting technique. It is stable sorting technique. So this is all about insertion sort. Okay, maximum and minimum number of comparisons, swaps. Maximum number of swaps. What are the maximum number of swaps and the minimum number of swaps? Although अभी तक question नहीं आया swaps के ऊपर, but if you know the algorithm, you can easily return it. What are the maximum and the minimum number of swaps in insertion sort? Maximum के लिए हमने example देखे reverse order में, so maximum number of swaps are n square. And if we talk about the minimum number of swaps, तो minimum में आपके पास कोई swap नहीं हो रहा, 0 0 0 0. So 0 swaps are there in the best case. So maximum number of swaps are n square, approximately n square, and minimum number of swaps are 0. So this is all about insertion sort. Are you all comfortable? Maximum is equal to n minus 1, but that is only for the nth pass. सिर्फ nth pass में n minus 1 आ रहा है. But जब आप number of swaps की बात करते हो तो आप total number of swaps return करोगे, right? So maximum के case में it is 1 plus 2 plus 3 plus 4 and so on up to n minus 1. Pass 1 में we were getting one swap. In pass 2 we were getting 2 swaps, 3 swaps, 4 swaps, and so on up to n minus 1. So this was nothing but it was n into n minus 1 divided by 2. I'm talking about the number of swaps. Same happened with the number of comparisons. Number of swaps are approximately it's n squared. So this is all about insertion sort. Anyone having any doubt in insertion sort? किसी को कोई doubt? Simple. Next one is selection sort. Selection sort says that नाम से क्या लग रहा है? Selection means what? What do you understand by the term selection? Let's say this is our array, input. Let's consider the index positions 1, 2, 3, 4, 5, 6, 7 and 8. What do you understand by selection? All clear. आपको मालूम है all clear का क्या मतलब है? So selection means किसी पर्टिकुलर एलिमेंट को सेलेक्ट करना. तो यहाँ पे हम क्या करेंगे? इन एवरी पास वी विल बी सेलेक्टिंग द ith एलिमेंट. कितने पासेस चाहिए? सी, अगर n एलिमेंट्स हैं, हर एक पास में आप एक एलिमेंट को उसकी करेक्ट पोजीशन पे रख रहे हो, तो टोटल नंबर ऑफ पासेस रिक्वायर्ड आर n-1. करेक्ट? क्योंकि फर्स्ट एलिमेंट, जब आप सिर्फ एक ही एलिमेंट को कंसिडर कर रहे हो और ओनली वन एलिमेंट इज लेफ्ट आउट, और directly or indirectly you are considering only one element, that means in that case no comparison, no swap is required, right? अगर एक ही element है तो वो sorted होगा ही होगा. Now we apply this concept here. कितने passes चाहिए? n-1 passes चाहिए क्योंकि n elements है. अगर यहाँ पे हम n count करते हैं, number of elements are 8 in this example. In every pass I'll consider the element और मैं मानूंगी कि वो element हमारे पास smallest element है. So in pass 1, let's start with pass 1. In pass 1 we are saying that minimum element is, how many passes are required? 1 से लेकर n-1 and every time we'll be going to the next pass. 1, 2, 3, 4, 5 and so on up to 7 passes are required. I की value कहाँ से कहाँ तक जाएगी? 1 से लेकर 7 तक, क्योंकि n पे एक एलिमेंट बचेगा और वो सॉर्टेड होगा. मिनिमम इज इक्वल टू आई फॉर पास 1, यानी कि फर्स्ट पास है तो मिनिमम हम क्या मान रहे हैं कि जो फर्स्ट एलिमेंट है दैट इज द मिनिमम एलिमेंट. आई एम जस्ट कंसिडरिंग द इंडेक्स. So at index whatever element is available that is the minimum element. अब बाकी के elements को हम linearly check करेंगे, is there any element which is smaller than 10? For that what we need is, we need to execute a loop. J will start from here. Okay, जो एलिमेंट आपने मिनिमम माना है उसके नेक्स्ट एलिमेंट से कंपैरिजन करना है whether a of j means jth इंडेक्स पे जो एलिमेंट है that is smaller than the element which is available at the minimum position. So 55 is smaller than 10? No, j will be incremented. 65 is less than 10? No, j is incremented. 5 is less than 10? Yes. तो डायरेक्टली स्वैप नहीं करेंगे, यानी कि अभी तक का हमारे पास जो स्मॉलेस्ट एलिमेंट है वो कहाँ पे अवेलेबल है? जहाँ पे j पॉइंट करे, दैट इज 4. दिस इज व्हाट आई हैव रिटन हियर. अगर ith पास है तो मिनिमम एलिमेंट विल बी कंसिडर्ड एट द इंडेक्स i. फॉर j इज इक्वल टू i+1, नेक्स्ट पोजीशन से स्टार्ट करेंगे एंड द गोल इज टू फाइंड आउट द मिनिमम एलिमेंट. अगर आपको स्मॉलर एलिमेंट मिल जाता है, इफ j इज पॉइंटिंग टू अ स्मॉलर एलिमेंट, तो हम मिन की वैल्यू को, मिन के इंडेक्स को अपडेट कर देंगे कि जो मिनिमम एलिमेंट है वो jth इंडेक्स पे. Okay, so this way will go through the complete iteration. Consider the next element. 15 is smaller than, अब min पे, a of min पे कौन सा element है? 5. Now the comparisons will be done with the element 5. 15 is smaller than 5? No. 25 is smaller than 5? No. 35 is smaller than 5? No. 20 is smaller than 5? No. We have reached to the end. So min is returning the smallest element, the position of the smallest element in the array. So smallest element कहाँ पे available है? At the index 4. Now what we need to do here is simply we'll be performing swap a of i. A of i means first element, first position पे smallest element आना चाहिए. So swap a of 1. A of 1 means first index पे जो element है and with a of min. Min is available at 4. This is what I have written here. जब ये execute हो जाएगी पूरी loop, that बाहर आके this is swapping a of i. इस केस में हमारे पास i की value 1 है और min कहाँ पे मिला? At the position 4. So this will result into an array. This will result into an array. सिर्फ दो ही elements swap हो रहे हैं, 5 and 20 will be swapped. Here we'll get 5 and 20. This was 10. 5 and 10. बाकी के सारे एलिमेंट्स एज इट इज आएंगे 15, 25, 35 एंड 20. आइडिया समझ में आया? तो बेसिकली व्हाट वी आर डूइंग इज कि जो भी आपके पास सब प्रॉब्लम है उसमें हम मिनिमम एलिमेंट फाइंड कर रहे हैं और इसको स्वैप करवा रहे हैं विद द पास ith पास. In the pass 2, now in pass 2 by the end of pass 1, one element is sorted. Now this is the sub problem where we need to apply the same concept. Now we'll be considering that minimum element is available at index 2. This is 1, 2, 3, 4, 5, 6, 7, 8. I'm assuming that the minimum element is at index 2. J kahan se start karega? From I plus 1, from third position. 65 is smaller than 55? No. 10 is smaller than 55? Yes. So 4. Then 15 is smaller than 10? No. 25 is smaller than 10? No. 35 is smaller than 10? No. 20 is smaller than 10? No. So minimum element in the remaining problem is 10. So we will be swapping these two elements. Now swap A of 2 and A of min. Min is available at index 4. तो जब ये swapping होगी, then we'll get here the elements as 10 and 55. इसमें इंडेक्स लेना होता है क्या? बिल्कुल. ये जो हमने रिप्रेजेंट किया है I, this is the index position. J is the index position. जब मैंने लिखा A of J यानी कि array A के अंदर jth index पे, obviously now it is going to return the element. ऑब्वियसली बात है कि जब कंपैरिजन होगा वो एलिमेंट्स का होगा, इंडेक्स पोजीशंस का नहीं होगा. सो इन दिस केस I, J and what else we have considered? Minimum. These all are having the index of the array. Okay. और जहां पे भी आपके पास आ गया array पे किसी particular index, that is representing the value. Clear? और कोई query? So this way we'll be doing the swapping. Now by this time, if you observe here, it's the same array. Okay, उसी में हम लोग swapping कर रहे हैं. So by the end of pass 2, we are having 5 and 10. 65 remains as it is. 55 was swapped. 15, 25, 35 and 20. अगर समझ में आ गया तो मैं सेम एरे में अब इसके बाद चेंजेस करूंगी. Now in the pass 3, now by the end of pass 2, two elements are sorted. This is sorted. अब pass 3 में हम क्या कंसिडर करेंगे? That minimum element is at index 3. This is the minimum element. In the remaining problem, we have to find out the next minimum. Every time we are selecting the minimum element and we are placing that on its correct position. This is the agenda of selection sort. That's it. Okay. So third element, third index पे जो element है, that is smaller. 65 is smaller. Then J will be starting from here. 55 is smaller than 65. Yes. So min will be updated. 15 is smaller than 55. Yes. So min will be updated as 5. यानी कि अभी तक का जो smallest element है, that is on index 5. 25 is smaller than 15. No. 35 is smaller than 15. No. 20 is smaller than 15. No. This means that index 5 पे जो element है, that is smaller. तो pass 3 है तो it will be swapped with the third element. So here we'll get 15 and here we'll get 65. This is the output of, so बाकी के elements as it is रहेंगे 5, 10, 15. Let me write here 5, 10, 15, 55, 65, 25, 35 and 20. So by the end of pass 3, three elements are sorted. We have to apply the same concept on the next pass. So let's quickly finish all the passes. So minimum will be initially considered as the element is available at index 4. 55. 65 is smaller than 55. No. 25 is smaller. Yes. So this is index number 6. 35 is smaller. No. 20 is smaller. Yes. So swap A of 4 with A of min. 4th position और 8th position वाले elements आपस में अब swap हो जाएंगे. So here we'll get 20 and here we'll get 55. Rest everything remains same. 65, 25, 35, 5, 10 and 15. So by the end of pass 4, 4 elements are sorted and we have to write all the passes, ma'am. I'm writing all the passes. बस ये एरे मैं बॉक्स में नहीं बना रही हूँ, डायरेक्टली एक सीक्वेंस दे दिए, बट ऑब्वियसली दिस इज इन द एरे ओनली. पास 3, min is starting from 3, pass 4, min is starting from 4. This is the output after pass 3, this is the output after pass 4. So anyhow I'm writing all the passes, don't worry. 7 passes are required, pass 5. Min will be considered as pass 5 may initially will be assuming that minimum element is at the index 5. This is the minimum element, 65. So we'll start the J from the next position. So 25 is smaller than 65. Yes. So min will be updated to 6. 35 is smaller than 35 is smaller than 25. No. 55 is smaller than 35. No. So this means that we got the min. So swap fifth position element with the sixth position element. So these two elements will be swapped. Here we'll get 25 and 65. बाकी सब कुछ same आ रहा है, 5, 10, 15 and 20. This is, I guess, अब image के पीछे जाएगा. This will be coming as it is 35 and 55. By the end of pass 5, 5 elements, first 5 elements are sorted. We have to consider the remaining problem. Go to pass 6. Pass 6. Minimum element is what? We'll assume that minimum element is at index 6. Now consider the element at the index 6. This is 65. 65, J कहाँ से start होगा? From 7th index. 35 is smaller than 65. Yes, so index will be updated. Then 55 is smaller than 35. No. So that means we have to swap 6th and the 7th element. So here we'll get 35 and 65. These two elements are swapped. Remaining everything is coming as it is. 5, 10, 15, 25, 20 and 25. By the end of pass 6, first 6 elements are sorted. We have to go to the next pass to sort the remaining elements. Pass 7. We'll assume that 7th element is the minimum element. Now, start comparing the element. 55 is smaller than 65. Yes. Arrays are over. Elements are over. So just swap 7 with the index 8. So this comes out to be 55 and 65. This is 5, 10, 15, 20, 25, 35. By the end of pass 7, first 7 elements are sorted. We are just left with one element, and to sort one element, no pass or no comparison is required. So we'll stop here. Make sense? So if you observe here, how many passes are we applying? और आप इस code को execute करके देख सकते हो. You can analyze this code. Here, outer for loop is there. This is starting from 1 and it is going till n minus 1. That means this loop is executing for n minus 1 times. It is executing for n minus 1 times. Inside this, there is one more loop. For loop के अंदर एक और for loop है, that is the inner for loop. How many times is this executing? Worst case mean this is starting from 1 and it is going till, or it is starting from 2 and it is going till n. This means that approximately this is also executing for n times. So what will be the time complexity? Best case है या worst case है? अगर मान लो आपके पास सारे elements given है in the sorted order 10, 20, 30, 40, 50, then also it is going to make these many comparison. बस फर्क कहाँ पे आएगा कि min की value update नहीं होगी और swap तो ये this is what, this is the mandatory swap. ये swap किसी condition के अंडर नहीं है. जब भी आप loop से बाहर आओगे, it's mandatory to swap element at the ith index and element at the minimum position. So this is the mandatory swap. Doesn't matter whether the element at the ith index or at the minimum index is same or not. This is mandatory swap. Mandatory है? Yes, what I'm saying is best case ज़्यादा से ज़्यादा क्या होगा, आपके पास जो input given है that is 10, 20, 30 and I want to sort these elements, so I'll be applying pass 1. Pass 1 में I'll assume that min is equal to 1. Minimum element is available at the index 1. Minimum element is available at the index 1. So this is the minimum element. Now I'll start the loop j from here. A of j is smaller than 20 is smaller than 10? No. 30 is smaller than 10? No. इसी तरीके से अगर आपके पास elements आते comparison होता, if you are not getting the minimum element, then min will not get updated. जब end पे पहुंचोगे तो बाहर आके आप क्या बोलोगे, swap a of I at the end of the loop, we are saying that a of I and a of min. But unfortunately, in this case, the value of I and min is same. Excuse me, guys. Are you getting this point? तो इस केस में आपके पास I की वैल्यू और min की वैल्यू चेंज ही नहीं हुई. So basically what we are saying is swap a of 1 with a of 1. Although result पे कोई फर्क नहीं आएगा, but इसने एक swap तो किया ही है. Correct? Swap a of I and a of min, value is same. But it has performed, it has made a call to the swap function. So that's why I'm saying that this swap is a mandatory swap. Doesn't matter whether you are getting the same value for I or min or you are getting the different value. And this loop is executing for n times. Inner loop is executing for n times. Outer loop is executing for n times. So in total, we can say that it is executing for n square times. टोटल कितने टाइम्स एग्जीक्यूट होगा, n स्क्वायर टाइम्स. अगर आपके पास एलिमेंट सॉर्टेड भी है तो भी एक एक एलिमेंट के लिए चेक करें. दिस मींस दैट बेस्ट केस एंड द वर्स्ट केस टाइम कॉम्प्लेक्सिटी इज, if we talk about the time complexities in the worst case it's n square, and in the best case also it's n square. Correct? If we talk about the number of swaps, then what are the minimum number of swaps and the maximum number of swaps? Swaps तो हो रहे हैं. What are the number of swaps? Number of swaps. Minimum number of swaps and maximum number of swaps. Answer? And average case 2 will be n square? Yes. It will be n square only. 1. 1 is the minimum number of swap. One minimum swap is required. यहाँ पे ये swap किसके लिए आया? This is for pass 1. In pass 2, again what will happen? I will be pointing to index 2 and min will also be pointing to index 2. तो pass 2 में हम लोग लिखेंगे swap a of 2 and a of 2. In pass 3, will be writing swap a of min. In pass 3, min will be I will be 3 and min will also be 3 if it's already sorted. Yes or no? The only difference in the best case is It's not changing the value of min. बस सिर्फ इतना फर्क है, यहाँ पे min की वैल्यू अपडेट नहीं होगी, अदरवाइज एवरीथिंग गोज सेम. तो in each pass there is one mandatory swap. Doesn't matter whether it's minimum number of swaps or whether it is best case or worst case. Best case में भी आपके पास mandatory swap आ रहा है. In each pass, okay, let me write here. In each pass there is one mandatory swap. One mandatory swap. अब चाहे वो आपके पास बेस्ट केस है या वर्स्ट केस है. बेस्ट केस और वर्स्ट केस में द change that is coming up, that is, in worst case it's updating the value of min, but in best case min does not get updated. So that means in simple terms we can say that the minimum number of swaps are n minus 1 and maximum number of swaps are also n minus 1. क्योंकि लास्ट पास में आपको चाहिए नहीं, टोटल n minus 1 passes are required, and in each pass there is one mandatory swap. In each pass there is one mandatory swap, and number of passes required to sort is n minus 1. Number of passes required are, it's n minus 1. Make sense? Yes. ये सबको क्लियर हुआ, राइट? Hurry up, guys. We have to talk about properties as well. So is it adaptive? When elements are already sorted, that is behaving as the best case. Anyways, let's talk about the properties. Yes. We have to check whether this is adaptive or not, it is in place or not. Is it adaptive? Is it in place? Is it stable? Swap is required. Definitely, ये लिखा तो है. What is happening? I've written this. Mandatory swap का क्या मतलब है? कोई फर्क नहीं पड़ता कि आपके पास i की वैल्यू अपडेट हुई है या नहीं हुई है. इसने क्या किया? a of i is 1, a of min is 1, तो swap a of i and a of min, तो ये एलिमेंट 10 से स्वैप होके सिर्फ 10 आएगा. स्वैप फंक्शन तो कॉल हुआ ही है. 20 will be swapped with 20 only, 30 will be swapped with 30 only. Read the whole question of mine. आप एक स्टेटमेंट में लिखा करो फिर. When elements are already sorted, then also n minus 1 swap is required. This is what I have explained here. One mandatory swap का क्या मतलब है? मैंने यहाँ पे लिखा भी है, जो आपने क्वेश्चन पूछा है प्रशांत, मैंने एग्जांपल लेके यहाँ पे लिखा है कि i और min की वैल्यू चेंज नहीं हो रही है, बट swap फंक्शन तो कॉल हुआ ना. पास 1 में we are making a call to the swap function. In pass 2 we are making a call to the swap function. In pass 3 also we are making a call to the swap function because this is mandatory. So that's why in if we are counting the number of swaps, minimum and maximum, क्योंकि अगर आप कोड में भी देखते हो, ये जो swap statement है, this is not available under the condition. Condition true होगी तो ही swap होगा, ऐसा नहीं है. Swap function is getting called. Exactly. Swap function को यहाँ पे अगर आप देखोगे, swap is a function. यहाँ पे दो parameters pass कर रहे हैं हम. लिखा तो मैंने यहाँ पे मेन फंक्शन भी नहीं है. वी आर टॉकिंग अबाउट द एल्गोरिथम्स, वी आर नॉट डिस्कसिंग, दिस इज नॉट अ क्लास ऑन प्रोग्रामिंग कि मैं पूरा प्रोग्राम लिखूं, है ना. तो जो मेन क्रक्स पार्ट है एल्गोरिथम का कि सिलेक्शन सॉर्ट वो कैसे करता है, आई जस्ट कंसिडर्ड दैट पार्ट. ओके, Okay, now focus on the properties. Is it adaptive? Is it in place? Is it stable? Adaptive है. Adaptive means worst case or best case में it is showing different behavior. Is it showing different behavior? No. This means that it is not adaptive. Not adaptive. Okay, let's talk about in place. Not adaptive. Let's talk about in place. Here is the example. Come on, guys. Now you know that how to find is it in place or not. In place, no. क्यों extra space ले रहे हो? Are you taking extra space here? मैंने सिंपल सा क्या बताया, इन प्लेस कब होगा, जब आप एलिमेंट्स को स्वैप कर रहे हो. एक ही एरे आपने मिन फाइंड किया और उठा के दोनों एलिमेंट्स को स्वैप कर दिया. ये तो डिफरेंट पासेस में शो करने के लिए आई रोट इट सेपरेटली. अदरवाइज स्वैपिंग का मतलब क्या है, उसी एरे में आप एलिमेंट्स की पोजीशन को बदल रहे हो. दैट्स इट. सो इट इज इन प्लेस. प्लीज कीप इन माइंड, जहां पे स्वैपिंग हो रही है तो वो पक्का से इन प्लेस है. दिस इज इन प्लेस सॉर्टिंग. इज इट स्टेबल? आप खुद सोच के देखो, यहाँ पे अगर आपके पास 50 है, 40 है, 30 है, सो 20. Just take an example. Now I want to sort these elements. So I'll find out the minimum element. Minimum element out of these elements is the minimum element is 20. So I'll swap these elements. I'll swap these two elements. Now in this problem, I'll find out the minimum element and I'll swap it. So I'll get 30 and 40. From the remaining problem, I'll be finding out the minimum element and I'll swap it. In the remaining problem, there is only one element, so it's sorted. So output will be 20, 30, 40, and 50. Where are we taking the extra space? We are not taking the extra space as we are swapping the elements in the same array only. So selection sort is one of the in-place sorting technique. What about stability? What about stability? If you use here like not less than or equal to a of min, then it is updating the value. So we can say that it is not stable, but definitely it can be made stable. This is not stable, but can be converted to stable algorithm. Correct? Swap means in place. Swap जब आप कर रहे हो, swap का मतलब क्या होता है प्रशांत? Guys, please don't get confused. What do you understand by swap? Let's discuss this logically. What do you guys understand by swap? Swap means एलिमेंट्स को आपस में इंटरचेंज करना. तो इंटरचेंज करने के लिए आर यू स्टोरिंग देम इन सम सेपरेट प्लेस? आर यू क्रिएटिंग अ न्यू एरे? आई होप यू आर गेटिंग माय पॉइंट. कोई कमेंट नहीं आया, इसका मतलब आई गेस इट्स क्लियर. सो We'll end our discussion here. So in today's session, we talked about two algorithms, two sorting techniques, insertion sort and the selection sort. I hope that this is clear to everyone. We talked about the number of swaps required, the properties of the sorting technique. In and out, शायद अब आपको algorithms ये दोनों clear हो गए होंगे. I'll share this PDF in the Telegram group. Okay. So you need not to worry about that. Please explain what. Write your full query in the chat. Temporary variable, is it dependent on the size of the array? अगर array में आपको 100 elements given है, how many temporary variables will you be considering? Or how many temporary variables you will be declaring? For 100 elements, अगर 100 elements है और आप एक एक करके elements को sort कर रहे हो, how many temporary variables are required? By the time we are getting the full query, let me discuss few points. So you guys can join the Telegram group. Prashant, I'm looking for your message. Please write your full query. Okay. So let's discuss this first. Swap. If I'm saying हमें दो एलिमेंट्स को स्वैप करना है, a of I and a of j, तो आप क्या करते हो? You are going to take here the temporary variable. Okay. और selection sort के केस में हमारे पास min है. बाद में आएगा कि मैम min के साथ कैसे करेंगे. So let me take min. अब I है या min है वो एक ही एलिमेंट है, राइट? सो बेसिकली व्हाट वी आर डूइंग इज वी आर स्वैपिंग. We want to swap. Swap means to interchange, change two elements. For this we are taking, आप बिना वेरिएबल क्रिएट किए भी कर सकते हो by performing the addition and the subtraction operations. So this swap can be done in two ways: by taking temporary variable with the help of one temporary variable, or it can be done without temporary variable. Yes. अगर इनफैक्ट अगर आप temp की हेल्प से भी करते हो, अगर विदाउट टेम्परेरी वेरिएबल कर रहे हो फिर तो बिल्कुल ही स्पेस नहीं चाहिए, नो एक्स्ट्रा स्पेस रिक्वायर्ड. हियर विल बी जस्ट परफॉर्मिंग सम arithmetic operation, so no extra space is required. If you are using the second concept with the help of temporary variable, so we are going to take here one temporary variable, we are going to initialize it with the value of a of I. For example, आपके पास I है, j है, value is 10 and 20, and temp के अंदर what I'm storing is जो भी I के अंदर value है. After that, we are going to store here a of I is equal to a of j. यानी कि I के अंदर कौन सी वैल्यू आएगी? जो j के अंदर है. And then a of j will be equal to whatever value is available in the temp. So that means temp is holding the value 10. So this is updated. Now I swapped a of 1 and a of 4. अगर यहाँ पे position change हो जाएगी तो temporary variable तो वही रहेगा. Anyhow you can store here the next value. अगर मेरे पास यहाँ पे 50 elements है, 10, 20, 30, 70, something like this, तो next time this I and min will change. Next time क्या change होगा? I की value और min की value change होगी. ये जो temporary variable है ये तो same रहेगा. जो भी है a of I में मान लो नई value यहाँ पे 100 आई, तो temp will get the value 100. So we need not to create one more temporary variable. ऐसा नहीं है कि अगर आपको 100 elements को sort करना है तो आप 100 temporary variables create करोगे. Correct? So 100 temporary variables, this is how the swapping takes place between a of I. This is the expansion of a of I and a of j. तो 100 एलिमेंट्स के लिए आप 100 टेम्परेरी वेरिएबल्स नहीं ले रहे हो. लेट अस अज्यूम दैट द प्रॉब्लम साइज इज n. एरे के अंदर आपको n एलिमेंट्स गिवन है, प्रॉब्लम साइज इज n. हाउ मेनी एक्स्ट्रा वेरिएबल्स आर रिक्वायर्ड? Just one temp variable is required. So is it dependent on the problem size? जितने वेरिएबल, one temp variable is required, so is it dependent on the problem size? अगर 5 एलिमेंट्स है तो भी एक ही टेम्परेरी वेरिएबल सफिशिएंट, अगर 100 एलिमेंट्स है तो भी एक से काम चल जाएगा, अगर 1 लाख एलिमेंट्स है तो भी एक से काम चल जाएगा. So this means that it is independent of problem size. Independent of problem size. So what is that? What is the space complexity? That is constant. Make sense? And in this algorithm, whatever we have discussed, we are not talking about a swap function in detail, but फिर भी मैंने आपको दोनों तरीके बता दिए कि कैसे execute करते हैं swap function को. So clearly it is not considering, it is not taking the extra space. Extra space होती है आपके पास n elements है तो n size का एक नया array चाहिए. We are not doing that. Any other query? So as you guys know that we have a Telegram group, that is Shefali ma'am Testbook. इसमें मैं PDF share करती रहती हूँ. So कल थोड़ा सा late हो गया था. Actually I forgot and I shared the PDF in the evening. But for today's session, I'll share this in another 5 minutes. You can check out the Telegram group, and in case still you have some doubt or query, you can post that in the group. Okay. You can also directly interact with me. Quiz and the poll. As already told you that this link is available in the description. So let's go to the description of the video. So here is the video. Okay. Let's go to the description. Here is the description. So first link is for the masterclass. In the masterclass, we are solving the previous year questions for all the topics. Yesterday, we had the discussion over the questions from algorithm and not analysis. We talked about the comparison of functions and asymptotic notations. In today's session, we will be discussing the previous year questions from recurrence relations. So we have a practice session at 8 p.m. Ma'am, do we have practice session at 7 p.m.? No, that's not possible, Prashant, because the slots are already fixed. So, second link is for the NIC super coaching. So, if super coaching, अगर आप NIC पे फोकस कर रहे हो तो आप सेकंड लिंक को फॉलो कर सकते हो. दिस इज द थर्ड लिंक. यू कैन सी हियर ज्वाइन गेट सुपर कोचिंग टेलीग्राम. तो गेट सुपर कोचिंग टेलीग्राम मींस अगर आपको ये वाला जिस ग्रुप की मैं बात कर रही हूँ, इफ यू वांट टू ज्वाइन दिस देन फॉलो दिस लिंक. एंड अपार्ट फ्रॉम दैट ज्वाइन सुपर कोचिंग गेट बैच. अगर आपको पूरा सिलेबस कवर करना है इन डेप्थ, क्योंकि यूट्यूब पे मैं हर एक चीज कवर नहीं करूंगी. ओके, सो विल बी जस्ट कवरिंग some portion of the subjects. So for that, if you want to cover it in detail, then you can join the super coaching gate. Currently sale is going on. Selection ka shanknath sale is going on. So in this you will be getting up to 90% off on the super coaching subscription. Okay, so for that you can use this code Shefali, SHEFALIS, to get this much discount. So for that obviously some code is required. And let me quickly take you to the Testbook website so that you can see what all things are available in the super coaching. Here we have the courses. Super coaching के अंदर आप एक ही कोर्स को multiple times cover कर सकते हो, that too from the various sources, from the multiple educators. So it's I'm going to the full course. So full course is available by the Gate Forum and by Digimento, by Nimbus Learning, and by me and my team. So you can see here 250 plus videos are there. ये सारी की सारी videos English में है. English means combination of Hindi and English, and the rating of this is 4.9. when you have a look over the full view course, तो आपको सारी सीरीज मिल जाएगी कि कौन कौन से सब्जेक्ट में कौन से टॉपिक के बाद क्या कवर हुआ है. Ma'am, are you going to teach all the subjects? No. But yeah, majority of the subjects will be covered by me. Okay. So this is about the full courses. Now here we have the profile of the super teachers, demo classes, live series, mock test and study notes. Study notes के अंदर आपको सारे notes मिल जाएंगे जैसे अभी मैं PDF share करती हूँ. So like that, here you will get the PDF of all the sessions with ink and without ink. Without ink means जो session में faculties लिखते हैं those things won't be included. एंड विद इंक में वो सारी चीजें भी आएंगी. तो हमारे पास सारे सब्जेक्ट्स के नोट्स अवेलेबल हैं. इंजीनियरिंग मैथमेटिक्स, जनरल एप्टीट्यूड, फॉर्मूला नोट्स एंड कंप्यूटर साइंस इंजीनियरिंग. कंप्यूटर साइंस इंजीनियरिंग में डिटेल में हर एक टॉपिक कवर किया हुआ है पीडीएफ की फॉर्मेट में. फॉर एग्जांपल प्रोग्रामिंग एंड डेटा स्ट्रक्चर्स में हमारे पास 5 यूनिट्स है, तो हर यूनिट से एक पीडीएफ आएगी. एल्गोरिथम्स मैंने 6 यूनिट्स में इसको डिवाइड किया है, सो 6 पीडीएफ नोट्स आर अवेलेबल. बट अभी मैं इसको इससे ज्यादा ओपन नहीं कर सकती हूँ बिकॉज दिस इज लॉक और ये अनलॉक होगा विद द सब्सक्रिप्शन, so I cannot go ahead. Okay. Difference between the detailed notes, difference between the computer science engineering notes and the formula notes is formula notes के अंदर हर एक सब्जेक्ट के लिए एक ही पीडीएफ है. That PDF will be containing 1 or 2 pages, which includes only the important notes and the formulas. ये इनिशियल स्टेज पे लर्निंग स्टेज पे काम के नहीं है, बट ये बहुत ज्यादा काम के है जब आपका एग्जाम आने में 1-2 महीने रह जाएंगे एंड यू हैव टू क्विकली रिवाइज द टॉपिक्स. ओके. तो उस टाइम पे हम डिटेल नोट्स नहीं पढ़ सकते, तो दैट टाइम विल बी रेफरिंग टू दीज फॉर्मुला नोट्स. So if you want to cover all these things, apart from this, mock test or test series will also be included in this one, in the super coaching. So under the super coaching, we have 3 plans available: 1 year plan, 2 year plan, and 3 year plan. 1 year plan आपको कूपन अप्लाई करने के बाद मिलेगा 10,799 and 2 year plan is available for 16,874 and 3 year plan is available for 21,599. Okay, but I recommend to go for 2 year plan if you are in second year or third year, but if you are in the final year then you can go for 1 year plan. 2 year plan इसलिए beneficial है, second year से preparation start कर दो, आपको इनफ टाइम हो जाएगा गेट प्रिपरेशन के लिए भी, प्लस यू विल बी एबल टू स्कोर वेल इन द सेमेस्टर एग्जाम्स का भी लोड नहीं आएगा. So it's completely your choice which plan you want to refer. Okay, so here are the 3 plans available. Now let me quickly tell you that what schedule we are following or I'm following for my live sessions. Okay, so here is the sale. For this benefit, you have to use here the coupon code, that is Shefali. S. Now, schedule. Yeah, in the next session we will be talking about heap sort, but sort से पहले we will be covering the concepts of heap tree. Heap tree कैसे बनाते हैं, adding the elements to the heap tree one after the another, or build heap method कैसे work करते हैं, कब build heap method use करते हैं, all these things will be covered in tomorrow's session. If you guys have any doubt or queries, please you can write that in the chat section. So Monday to Friday, don't get confused with the timings. मैं timings change नहीं कर रही हूँ. It's same for all the days. At 4 p.m. guys, we are having the YouTube session. और जो master classes है वो भी free है. Anybody can attend those classes. Timing is 8 p.m. Although this is half an hour session, but questions करने के लिए काफी है. This is Testbook master class, and obviously there is no fee or no restriction on attending the number of master classes. In the YouTube sessions, we are covering the concepts, and in the master class, we are solving the questions. So PYQs from GATE are solved in the master classes. But मैं topic by topic ले रही हूँ. Topic कौन सा चल रहा है जो already हम YouTube पे cover कर चुके हैं. Okay. सैटरडे एंड संडे वी हैड द डिस्कशन ओवर द रेक्रेंसलेशन. तो इस सैटरडे संडे से पहले मतलब आज और कल इन दो सेशंस में हम लोग रेक्रेंसलेशन से सीधे क्वेश्चंस कैसे आए हुए हैं वी विल बी डिस्कसिंग दोस क्वेश्चंस. सैटरडे एंड संडे I'll be taking two sessions, one at 6 p.m. but ये variable है, not sure. This can be the for the gate, marathon for gate. This session will also be on YouTube. And at 9 p.m. surely we'll be having this 9 p.m. session क्योंकि जो ISRO के sessions ले रही हूँ मैं अभी इस time पे, those are on weekends only. This is completely for ISRO. कंप्लीटली फॉर इसरो का मतलब ये नहीं है कि सिर्फ जो लोग इसरो का पेपर देना चाहते हैं उनके लिए बेनिफिशियल है, जो लोग गेट की प्रिपरेशन कर रहे हैं उनके लिए भी बेनिफिशियल है, बिकॉज वट एवर क्वेश्चन आई बी डिस्कसिंग हियर those will be beneficial for the ISRO students. तो जो लोग इसरो की प्रिपरेशन कर रहे हैं बेटा, मेरी सजेशन ये है कि आप गेट वाले सेशंस अटेंड करो, और जो गेट की प्रिपरेशन कर रहे हैं वो इसरो वाले भी कर लो. आपको एक अलग तरीके से क्वेश्चन कैसे आ सकता है वो चीजें मिल जाएंगी. ओके और जिन लोगों ने इसरो का फॉर्म नहीं भरा है, क्विकली फिल आउट द इसरो फॉर्म. डेडलाइन फॉर फिलिंग आउट द फॉर्म इज 14th of June. मैं हर सेशन में आपको बता रही हूँ, एंड पे अगर छूट गया यू गाइज गोना रिग्रेट इट. Don't wait till the last date. Okay, and the age limit is it's 28 years. Age limit is 28 years. So this is all from my side. If you guys have any query, you can ask. Definitely, we'll be having the session today at 8 p.m. in which we'll be covering the PYQs on solving reconciliation. I discussed three methods: recursive tree method, substitution method, basic master's theorem, and extended master's theorem. So we'll be using those concepts. So solving recurrence relation. जिन लोगों ने सेशंस नहीं देखे थे अभी भी आप देख सकते हो, 1 घंटे का सेशन है. दोनों दिन का मिला के it will be around somewhere around 2 hours, and you will get all the concepts. Okay, any queries? I guess there is no queries, so we'll end our discussion here. I hope the session was useful. यार अगर आपको सेशंस चाहिए और आपको लगता है कि सेशंस अच्छे होते हैं, प्रैक्टिस हो रही है आपकी, तो कम से कम वीडियो को लाइक तो कर दिया करो. सो उससे क्या होता है कि आई गेट द मोटिवेशन. जैसे आप लोगों को मोटिवेशन चाहिए होता है, सिमिलरली आई टू वांट द मोटिवेशन, राइट? Alright, so those who have not subscribed for the channel, guys, subscribe the channel, join the Telegram link, and keep liking the videos. And I'll see you in tomorrow's session at 4 p.m. But उससे पहले एक बार हम आधे घंटे के लिए मिलेंगे 8 बजे with the PYQs on reconciliation. So thank you so much, guys. God bless you. Take care. Bye bye.